In this video clip we develop a solution to exercise sheet 3, question 2. In this question we're asked to re-examine the model in question 1, which was a VAR1 process, for the specific parameter values that were a stationary process, and this time to calculate 1 and 2 step ahead predictions. So first let's remind ourselves of how we interpret prediction in this context. Our prediction of yt plus h is interpreted as the conditional expectation of yt plus h given the information available up to time t. That's the values of the series up until that time. In A, we're asked to do the 1 step ahead prediction. This amounts to setting h equal to 1. So we start by writing a representation for yt plus 1, the thing we want to predict, based on the model, which we have here. And then we use that to derive our conditional expectation. Our conditional expectation of yt plus 1 will just be alpha plus phi 1, then our expectation of yt. Now yt is in the information set, so we can just replace it by its own value. And then plus the conditional expectation of the error. Okay. Now that expectation of the error is going to be 0 because epsilon is white noise in this model and so unpredictable given information about the series. Okay, so now using that formula for the specific process that we're given in the question, our prediction will be then alpha plus then putting in the values for phi, and then we substitute in the values we're given in the question for y1t and y2t, 4 and 15. The answer becomes 3.7 and 14.2. Notice the first element is our prediction of y1 t plus 1, and the second element is our prediction of y2 t plus 1. And now we're asked to do the 2 step ahead prediction, which amounts to setting h equal to 2. Process is the same. We write out a model for yt plus 2. It's given to us in the question. That's the VAR1 process. And then we take the expectation of both sides, conditional on the information set. So we get y hat t plus 2 will be alpha plus phi 1. And then we want the conditional expectation of yt plus 1 given the information set, which is just y hat t plus 1 calculated in the previous part. And again, the expectation of the error is 0. So then plugging in the specific values, again putting in value for alpha, the value for phi, and now we substitute in the values for our predictions calculated in part A, and then multiplying it all out we find the answer is 3.44 and 13.50. Okay. Part C, we're asked to say what will happen to our prediction as the forecast horizon h tends to infinity. Remember that because this is a stationary process, our conditional expectation of yt plus h will converge to the unconditional expectation as h tends to infinity. And so our forecast will converge to the values of 1.5 and 8.0, which are the unconditional mean of the process calculated in question 1 part B. And I missed that plus 1 off there in the epsilon.